So welcome to InfoScience Education. In this video, we were discussing the experiment to determine the refractive index of a prism by using a spectrometer. First, we can look the aim of this experiment. So aim of this experiment is to determine the refractive index of a material of the prism. Now we are moving to the apparatus required for this experiment: a spectrometer, a prism, a sodium vapor lamp. These were the apparatus required for this experiment. Now we can move to the theory of this experiment. So in this experiment we were using the equation for finding the refractive index. Here n equal to sin a plus d by 2 by sin a by 2, where a is the angle of the prism and d is the minimum deviation. These were the two parameters which we were finding using the spectrometer in this experiment. Now we can move to the procedure of the experiment. Here we are using two different procedures. First one is to find the angle of the prism A, and second one is the procedure to find the angle of minimum deviation D. These were the two procedures which we were carrying out through this experiment. So now we can move to the first section of the experiment. So here we have taken a sodium vapor lamp, a prism and a spectrometer. First we have to focus the spectrometer using a distant object, and here we have noted the least count of the spectrometer. So first one, main scale division equal to half degree, which is equal to 30 minutes. Number of vernier scale division, which is equal to 30. So we are getting the least count as 1 MSD by number of VSD, which is equal to 1 minute. Now we are moving to the focusing of this spectrometer telescope. So at the bottom left corner you can see a telescopic view, which is the view from the telescope of this spectrometer, and now you are getting a blurred view. So for correct focusing you have to adjust the telescope key and get a clear distant image. For that you have to adjust the key as shown in this video. This is the key which is used to focus the telescope and try to get a clear distant image. Now we get a clear distant image without parallax. So after clearing this, you should not touch any of the telescope key, and all the adjustment should be done on the collimator. Now we have focused the telescope by using a distant object, and now we are focusing the slit from the sodium vapor lamp, and now adjust the collimator to get a narrow and clear slit. Now we get a clear slit and try to adjust it to the center of the crosswire. Now we have arranged the slit to the center of the crosswire. So all the initial adjustment is over. So it's the time to put the prism on the prism table. So now we are moving to the first procedure to find the angle of the prism A. For finding the angle of the prism, this is the diagram which we are following. So here the prism will have three surfaces. One is a blurred surface and two are the reflective surface. So first we have to take the angle from the AB side, and then we have to take the angle from the AC side. So the tabular column is as shown here. Reading of the reflected image at the first surface, vernier 1 and vernier 2 readings should be taken, and on the second surface, that is AC side, readings of the reflected image at the second face. For that also we have to take the vernier 1 and vernier 2 reading, and for calculating the angle of the prism we have to take the difference, which is equal to 2a, and from that we can find the angle of the prism. Now we are starting the experiment for the first procedure. So for that, place the prism as I mentioned earlier. The prism have three surfaces. One is a blurred surface and two are a reflective surface. So the blurred surface should face to the telescope and other side should be on the other sides. For first we have to denote the sides. For finding the slit, we have to move the telescope to the either sides of the prism. So we have here denoted the prism sides as AB and AC. For now we are first finding the slit through the AB side. So move the telescope towards the AB side and find the slit through the telescope. While we are moving, we have got a slit from the AB side. So now focus the clearly move the slit towards the center of the cross wire. Now we have move the slit towards the cross wire, and now we can take the readings from vernier 1 and vernier 2. Here we are getting the vernier 1 as 236.5 degree and vernier 2 as 56 degree. Note these values on the tabular column for the first phase. Now we are looking for the slit through the AC side. So move the telescope towards the AC side and find the slit through it. Move the telescope until you get a slit. Now we got a slit, and now we have to focus it to the center of the crosswire. So now we are moving the slit to the center of the crosswire by adjusting the telescope, and now take the vernier 1 and vernier 2 readings. So in this experiment, for the AC side, we are getting the vernier 1 reading as 116 degree and 20 minute, and vernier 2 as 295.5 degree respectively. So note these values to the second phase column. So our first experiment is over. First part of this experiment is over. To find the angle of the prism, now we have the calculation. So here we have noted all the values on the tabular column. Reading of the reflected image at the first phase, vernier 1 reading equals 236.5 degree and vernier 2 equals 56 degree. And for the reading of the reflected image at the second phase, we have got vernier 1 as 116 degree 20 minute and vernier 2 as 295.5 degree. And difference 2a, we are getting the difference from the vernier 1, which is equal to 120 degree 10 minutes, and vernier 2 120 degree 30 minutes, and mean 2a equal to 120 degree 10 minutes, and from that we can calculate a as 60 degree 5 minutes, which is the angle of the prism. Now we are moving to the second procedure to find the angle of minimum deviation, which is denoted as D. So this is the diagram which we are following to find the minimum deviation of this prism, and this is the tabular column. From this we have to calculate the refracted image vernier 1 and vernier 2 reading and the direct image. From that we can calculate the difference D. So here we have to place the prism at 90 degree from the previous adjustment. So we can move to the experiment. So we have to, as I mentioned earlier, we have to rotate the prism to a 90 degree from the initial adjustment. Now we have rotated the prism to a 90 degree. So you should also follow this procedure as you do the experiment in the lab. Now the telescope is turned to view the refracted image of the slit. Looking through the telescope, the vernier table is slowly turned in such a direction that the refracted image move towards the direct ray in the direction of decreasing of angle of deviation. The telescope is also rotated so that the image of the slit is always in its field of view. It will be found that at a certain point the image will become stationary for a moment and then turns back. So this is the minimum deviation position which we have find out. So now we have to move the telescope and centerize the narrow slit to the center of the crosswire. So for that, just move only the telescope, do not touch to the prism or the vernier table. Just move the telescope and focus the slit to the center of the crosswire. Now we have focused the slit to the center of the crosswire, and we have to find the readings from vernier 1 and vernier 2. So here we are getting the vernier 1 as 196 degree 20 minute and vernier 2 as 60 degree 20 minutes. So these were the values which we have to noted on the refracted image column as vernier 1 and vernier 2 respectively. So now we have to find the direct image. For finding the direct image, just remove the prism from the prism table and do not rotate the vernier table. Just rotate the telescope and focus it directly to the collimator to find the slit through it. Now we get the slit through the telescope and move it to the crosswire, And now we are taking the vernier 1 and vernier 2 reading. So from vernier 1 we are getting the angle as 156.5 degree 10 minutes and vernier 2 as 336.5 degree 10 minutes. These were the two values which we have to note on the direct image column. So our experiment procedures is over. We have find out the refracted image and also the direct image. So now we can move to the calculation part of this experiment. Now this is the calculation column which we are following for the to find the angle of the minimum deviation. So refracted image vernier 1 reading equals 176 degree 20 minutes and vernier 2 equals 60 degree 20 minutes, and direct image vernier 1 reading equals 156.5 degree 10 minutes and vernier 2 readings 336.5 degree 10 minutes. So we are getting the difference D as both of the vernier 1 and vernier 2. So mean D equal to 39 degree 40 minutes. Now we are moving to the calculation by substituting this value. So we are using the equation n equal to sin a plus d by 2 by sin a by 2. So mean a equal to 60 degree 5 minutes and mean d equal to 39 degree 40 minutes. While substituting the equation, we are getting sin 60 degree 5 minutes plus 39 degree 40 minutes by 2 by sin 60 degree 5 minutes by 2. By substituting the values, we are getting 1.527. So this is the refractive index of the material of the prism. So this is the experiment which we are carrying out for finding the refractive index by using a spectrometer. So now we are moving to the result part. This is the result. Refractive index of the material of the prism equal to 1.527. So this is the experiment. So hope you all understand well. So please leave the comment about this video. See you on the next video. Then thanks for watching.